Hello dear JEE mains aspirants, how are you? I hope so you are doing great. This is Lakshmi. Once again welcome to my channel Math Super Tips and Tricks. In this channel I am going to teach the various levels of examinations, especially objective type, with amazing super tips and tricks I am using in my videos. If you not yet watch my videos till now, please watch them whose links are there in below description. Those are mostly helpful to you to crack any type of question, any chapter easily within fraction of seconds. You can get the solutions, quick solutions you can get because I'm using the super tips and tricks. Yes, I started the quick revision maths for JEE mains. Quick revision is mostly helpful to you for your final examination because in this quick revision I'm going to teach all important topics with concept, tips and tricks clearly, briefly. So I will explain. Those are most helpful to you for your final revision. So already I did one part. In that part I discussed about the mathematical reasoning. What are the various tips and tricks? What is the concept of mathematical reasoning? And what are the questions depends upon the various points on the mathematical reasoning. I did in quick revision part 1. Now in this today's session I am going to teach the part 2, one of most important major chapter, that is matrices. In that, how can you solve the linear equations of 3 variables? It is very important point under the matrices, solving of linear equations in 3 variables. 99.99% one question is given from this topic. Are you ready to watch? Without delay, let's get started. In this part of quick revision, what is said, I am going to revise matrices, and in this matrices, how can you solve the linear equations of 3 variables? For that, you have to know what is a brief revision, what is a concept you have to know first of all. So, linear equations of 3 variables has 2 types of systems you have to know first. What are those? Linear equations of 2 types of systems, those are, one is non-homogeneous system, another is homogeneous system. Look at this one. There are the 3 equations here. A1x plus b1y plus c1z plus c1z is equals to d1. a2x plus b2y plus c2z is equals to d2. Same way third equation, a3x plus b3y plus c3z is equals to d3. Such type of system is called as non-homogeneous system of 3 variables x, y, z. Clear? It is can be written in the matrix form Ax is equals to D form. Ax is equals to D form, where A is a quotient matrix. What are the quotients of x, y, z? You can get the idea about this one. First equation, there are the A1, B1, C1 are quotients of x, y, z is taken as a first row, and A2, B2, C2 quotient of x, y, z is taken as second row. Same way third row. This is called as quotient matrix. How can you get it? It is formed by the quotients of x, y, z, like it is denoted as A. Now, how to choose one more matrix, that is, I have taken some letter B. It can be formed, first A contains the, what are the elements in A, you know that clearly. In this system last is equals to something is there, that is D1, D2, D3. Those are called as constants. It is denoted as a D. If the first column is replaced by days, we can get the one of the B like this, D1, D2, D3. Remaining 2 columns are as it is. Maybe we can replace the second columns with the D's, D1, D2, D3 in A. First, third are as it is. Similarly, what you can guess about this one? Last column is replaced by D's. First 2 columns are as it is. That is denoted as some letter B matrix. Either this or that, this one. So these we can use wherever maybe, whatever maybe we need, that one you can choose. Clear? So how can you collect the A, B? How to know first of all? This is called as which system? Non-homogeneous system. Now, what are the types of solutions? Non-homogeneous system, it contains, you have to know. So those are the solutions of non-homogeneous system. There are the 3 types of solutions. One is unique solution. Second one is infinitely many solutions. Third one is no solutions. If the system has unique solution and infinitely many solutions, the system is called as consistent. The system is called as consistent. If there is no solution, the system is called as inconsistent. Okay, when the system is inconsistent, it doesn't have the solution. When the system is consistent, either unique solution or infinite many solutions, means it must be have the solution. Clear? Now, what are the conditions for unique solution and infinite many solutions? No solution you have to know from the non-homogeneous system. Here I am using the verification of unique or many or no solutions. I am using the only determinant method for easiness purpose. Another method is there, finding the rank. It is somewhat lengthy and difficult. But determinant you know very well, easily you can do the determinant. That's why I am using the determinant method. What is the condition when the system of non-homogeneous has a unique solution when the det A not equals to 0. When it has unique solution, det A not equals to 0. You know A is what? We can find out its determinant. If det A not equal to 0, we can confirm that it has a solution, unique solution. If the det A is equals to 0 and det B one of them, any one of them is 0, that is called as infinitely many solutions. What are the conditions for infinitely many solutions? Det A is equals to 0 and all of det B is equals to 0. At least one of them you can check, depends upon the given question. We can choose the B, I said already. So, these are the conditions when the unique system has infinitely many solutions. Det A 0 and det B 0. Now, come to the no solution. When it has a no solution, when the det A is equals to 0 but det B not equals to 0. That's it. It is simple way you have to revise. This is quick revision. Already entirely matrices chapters. A chapter I did the 5 to 6 lectures whose links are there in the below description. You can watch it. Today, quick revision, I am going to teach linear equations of 3 variables. What are those? Okay, let's solve it. We will discuss one by one. First, you have to know briefly about the concept. Then we will do the sum of the questions also. Clear? What I said about this part? In this part, what do you know? You have to know. What is system of non-homogeneous? In this, what are the A and B as well as harmonious solutions? It has what are the types of solutions you have to get. What are the conditions important here? When it has unique solution, you can conclude that det A not equals to 0. When it has infinitely many solutions, det A 0 and det B is also 0. When it has a no solution, when det A 0 but det B not equal to 0. This is briefly about the non-homogeneous system. Now come to the homogeneous system. In the homogeneous system, the matrix form we can write Ax is equals to O. We can observe that here all these D1, D2, D3 are some constants are available in the non-homogeneous system. But in case of homogeneous system, all constant becomes 0. That is called as homogeneous system. In case of homogeneous system, it has a unique solution, infinitely many solutions, means it is always consistent. Always consistent. It has two types of solutions. You have to know other names also here. In case of homogeneous system especially, how you recognize the system is homogeneous? Yes, all constant must be zeros. Now, how many types of solutions it has? Two types of solutions only it has. Unique solution as well as infinitely many solutions, and the system is what? Always consistent. And here one more point you have to recognize. What are the other names of unique solution, infinitely many solutions? In case of unique solution, we can call it as trivial solutions. It is also known as zero solution. Unique solution is also called as what? Trivial or zero. So you have to know the alternate names. You may give the any name, but conditions are what also you have to know. So that's why you can follow carefully. Now, as usual, here there is no question of the D. No D means there is no question of B. So only we have to concentrate on A. In this case of homogeneous. Here what is the unique solution condition here? Det A not equals to 0, right? Same only here also. And infinitely many solutions, what is the condition? Det A is equals to 0. That's it. In case of homogeneous system, unique solution is also called as what? Zero solution is also trivial solutions. That is condition det A not equal to 0. Infinitely many solutions. Non-trivial solutions it is also called as non-zero solutions. What is the condition? Det A is equals to 0. These are the very simple points I have explained clearly, briefly for quick revision. So by depends upon this one, mostly 99.99% one question is given in every shift. That's why don't neglect at any cost. Is it clear? Just you have to go through once from your side. It's very easy. So how can you apply this? This is determinant method I used for easiness purpose. How can you crack the questions? Few of the questions I will do. Are you ready? I'm going to do the few of the questions which are depends upon the linear equations of three variables. Look at the question number 1, which is given January 1 of the batch 2020. What is given here? If the system of equations has more than two solutions, then is asking mu minus lambda square. In the system of equations, there are two unknown values, lambda and mu. We can find out those values and finally we can get the resultant value of mu minus lambda square. This is given in a numerically valued based question. So under the numerically valued based questions, you know that clearly no options there. We can get the solutions in the decimals, maybe integers, etc. So how we can get it? It has how many solutions? More than two solutions. And we can look at this system of equations. First of all, we have to recognize the given system is homogeneous or non-homogeneous. This is clearly which system? Yes, exactly, non-homogeneous, because there are the constants here. In case of non-homogeneous, there are the three types of solutions. I said it has more than two solutions, means indirectly not a unique solution, not no solution. It has indirectly infinitely many solutions. More than two means not unique in the sense indirectly we have to use infinitely many solutions conditions. So there are the two types of conditions, infinitely many solutions. First condition is what? Det A is equals to 0. Det A is equal to 0 means det of, what is A here? Coefficients of x, y, z in the first equation. 1, 1, 1 is taken as first row. Can you guess second row? Yes, 1, 2, 3. Second equation, coefficients of x, y, z from the second equation. From the third equation, 3 to lambda is equals to 0. Indirectly, it is given that infinitely many solutions. That's why I use the first condition is that A is equals to 0. And what is expansion of this is 1 into 2 lambda minus 6. Determinant expansion. 2 lambda minus 6 with minus 1 of 1 into lambda minus 3 is 9 plus 1 of 1 into 2 minus 2 6 equals to 0. It is simply 2 lambda minus 6 with minus lambda minus 9 plus 9. 2 minus 6 is how much? Minus 4 is equals to 0. From this 2 lambda minus lambda is lambda with minus 6 minus 9, minus 6 minus 4 minus 10. Minus 10 plus 9 is minus 1 equals to 0. We got the lambda value is 1. We got the lambda value is 1 by using which condition? What is one of the condition here? Det A is equals to 0 condition I used. Now, what is another condition? One of the det B 0 we can take better. So, how can you choose the B? I said to you, we can miss the either A column, maybe B column, C column. In place of that one, we can replace the D elements. Here, we need the unknown values. Unknown values are there in the D columns as well as C columns. Means you don't miss the C at any cost. We can miss either A or B. Okay. Already lambda value got it now. That's why no need to worry about the C column. We can no need to take the C column. I'm using the simply B as det B as det of first element. First elements I'm taking 1 1 1 like 1 1 3 1 1 3. Second column also I'm taking 1 2 2. In third column 1 3 lambda. Already lambda we got, that's why you can miss this one. In place of this is I'm replacing the D's, that is a 6 10 mu is also 0. Okay, right. Whatever may be win that one, we need that one, you have to concentrate in case of B. Now we can expand it. 1 into 2 into mu is 2 mu with minus 20 with minus 1 of mu minus 30, right? Plus 6 of 1 into 2, 2 minus 2, 3, 6 equals to 0. So this value is a 2 mu with minus 20 with minus mu, right? Minus of minus plus 30 plus 6 into 2 minus 6 is minus 4 equals to 0. Again, I am rewriting as 2 mu minus mu is mu, right? Constants minus 20 plus 30. Here 6 into minus 4, 6 4s are 24 equals to 0, right? Now we can simplify this value again. Mu, here minus 20 minus 24 minus 44 with plus 30 equals to 0. Therefore, mu minus 44 plus 30 is minus 14 is equals to 0. Therefore, mu value is a 14. We got the mu value is a 14, lambda value is 1. Lambda is 1, mu is a 14. What do you want? Mu minus lambda square. Therefore, mu minus lambda square is 14 minus lambda square, 1 square is 1 only. 14 minus 1 is 13. This is our required result. Lambda minus, mu minus lambda square is a 13. That is only this answer. This is numerical valued based question. Clear? What I used here? It is clearly non-homogeneous system. I used the infinitely solutions conditions. Clear? Now we can look forward some more questions. Look at the next question. In this question, given that the system of equations has non-trivial solutions. Has which solutions? Non-trivial solutions. I said to you, in case of homogeneous, there will be unique solution is also known as trivial solution. Infinitely many solutions is also known as non-trivial solutions. You can recognize clearly this is a homogeneous system because all constants are zeros. That is one way you can recognize. And given that non-trivial solutions, it is clearly 100% homogeneous system. What is the condition for non-trivial solutions? So exactly det A equals to 0. Det A equal to 0 you have to take. Det A is equals to 0. That is det of 1 lambda minus 1, 1 lambda minus 1, lambda with minus 1 minus 1, lambda minus 1 minus 1 as second row, third row 1, 1 with minus lambda is equals to 0. From this we can find out lambda values. He is asking the infinitely many values of lambda, maybe exactly one value, maybe two values, three values. By finding only, after finding only can get recognize which of is correct one. So can expand the determinant, you know very well. What is the expansion now? 1 into minus 1 into minus lambda is lambda with minus or minus plus 1. Then with minus lambda here, minus lambda you can use closing these two, lambda into minus lambda square, right? Minus 1 into 1 minus 1 minus of minus plus 1. Next minus 1 of closing these two, lambda into 1 is lambda with the minus or minus plus 1. Lambda plus 1 is equals to 0. Therefore, this is we can expand like this. Lambda plus 1 with the minus of minus plus lambda cube with the minus lambda with minus 1 is equals to 0. Next step, lambda cube, then 1 minus lambda plus lambda gets cancelled here. One more minus lambda is left over. Then plus 1 minus 1 also cancel, it becomes 0. Now what we can take? Lambda we can take common, lambda square minus 1 is 0 is left over. We got the two factors here. One is lambda is 0. What is another factor? S. Lambda square minus 1 equals to 0. From this we can write lambda square is a 1. Lambda is equals to plus or minus 1. Root 1 we can take as plus or minus 1. Therefore, how many values of lambda we got? Lambda 0, 1 value, minus 1 value, plus 1 value. There are how many values? Exactly, there are 3 values of lambda. Therefore, which of is correct one? Exactly 3 values of lambda. It is clearly fourth option. It's a very easy question. It's very clear. Is it clear? There is no difficult at all. Just we have to use that A is equal to 0. From that we can find out lambda value or values. That is only we did it from this question. Clear? Come to the next question. Number 3, the system of equations is given that inconsistent. Given that clearly system is inconsistent, and also we can recognize by the given system constants are available here, mu 1 lambda. That's why this system is clearly non-homogeneous system. Inconsistent conditions are what? There are 2 conditions. What are those? Det A 0 and det B not equals to 0. If take the det A is equal to 0, what happened? In A place, there are the elements 3, 4, 5, 1, 2, 3, 4, 4, 4. If take the A, det A automatically 0. There is no purpose to take the A because of there are no unknown values here. Unknown values are there in the constants. That's why there is no question of verification of det A 0. That's why I am not concentrating on det A is equals to 0. Now we can take det B is equals to 0, not equal to 0. If you check even the det A, automatically it is 0 only. No need to check it because there is no unknown value in the quotient matrix. Next, det B. Det B, I am taking any column you can miss. I am taking the 3, 4 and mu. I am missing the third column, like det B not equals to 0. We have to take det of 3, 4. I am missing 5, mu I am taking. Right. 1, 2, 1, 2. I am missing the 3, 1 I am taking constant. And the 4, 4. I am missing this 4 and the delta is not equals to 0. So what we can find out finally, then we have to find out delta mu can be. Order pairs delta and mu we have to get. First of all, what is the expansion of this is, we can check it. What is this expansion? 3 into, expand it, right? 3 into 2 delta, 2 into delta, 2 delta with minus 4 into 1, 4, right? And with minus 4 of closing these two, delta into 1 is delta, with 4 into 1 is 4 with minus 4. Then plus mu of, for mu we can close it, 1 into 4, 4 minus 4 into 2, 8, which is not equals to 0, we have to take. Now next, expand it, 3 into 2, 6 delta with minus 3, 4, 12, minus 4 delta, minus 4 into delta, minus 4 delta, is it clear? Minus into minus plus 16, plus 4 mu with minus 8 mu. Actually, we can simplify this is 4 minus 8 is minus 4, like that we can take. Already expand it, that's why no need to worry. 6 delta minus 4 delta is how much? 2 delta, right? Now mu's, 4 mu minus 8 mu is minus 4 mu, right? Constants, minus 12 plus 16 is plus 4, which is not equals to 0. So from this we can take the 2 is common, 2 gets cancelled. What is left over here? Delta minus 2 mu with plus 2 not equals to 0. By options verification, what about first option? 4, 6. Verify the 4, 6 here in place of delta and the mu. Delta is a 4, mu is a 6. 6 to 12 plus 2 not equals to 0. Maybe second option. First option. Second option, we'll check it. 3 in place of delta 3 and mu 2 into 4, 8 plus 2. It is also not equals to 0. Third option. 4, 3 in place of delta 4 with minus 2 into 3, 6 plus 2 is equals to 0 here. No, now fourth option. 1, 0 in place of delta 1, mu 0 means it is 0 plus 2. 1 plus 2 is not equals to 0. Actually, in this question, we have to find out delta mu can be is given. Can be means there are the 1, 2 and 4, 3 options. Is it possible? Only one option is only correct option. Means it must be, cannot be, it seems. Therefore, which option is the correct one? It is clearly third option. So, third option, for third option only, it is odd man out. Out of 4 options, it is only different among the remaining 3, 1, 2, 3. 1, 2 and 4 options are not equal to 0. Only third option is only equal to 0. Therefore, we can pick up the option number 3 here. That is our required solution for this question. Is it clear? Now we can come forward some more questions. Right? See the next question number 4. What is given here? If 3 of the equations are given, then which option is correct one? The question only equations are given, we have to recognize which is the correct option. So first of all, you have to recognize what is the given system. Homogeneous is or non-homogeneous? Yes, it's clearly homogeneous because all constants are zeros. In case of homogeneous, you know that clearly there will be 2 types of solutions. What are those? Yes, unique solution or infinitely many solutions. When it has unique solution, then the det A not equals to 0. So first we can concentrate on det A is what? Det A 0 or not? Det A we can check it. Det A, det of 7, 6, minus 2. Then second row 3, 4, plus 2. Third row 1, minus 2, minus 6. We can check it, is it 0 or not? Its value you can check. 7 into 4, 6, 24 with minus 24. Next, with minus 4, minus plus 4 will come here. Next, minus 6 we can use. You know determinants expansion very well. How can I expand the determinant? You know very well. That is what I am doing here. Minus 6 we can take here. We can change the sign. Minus 6. See, now 3 into minus 6 is minus 18. Next, minus 1 into 2 is minus 2. Next element is minus 2 times of. Minus 2 you can close it. 3 into minus 2 minus 6 with 1 into 4 4 with minus 4. Right. Now 7 times of minus 24 plus 4 is minus 20. Minus 6 times of minus 20 here also. Minus 2 times of minus 10. Right. You know 720 is 140 with minus. Minus into minus plus 6. 20 is 120 with plus 20. You know that clearly here minus 140, here plus 140. Minus 140 plus 140 becomes 0. Det A is equal to 0 means what? Is it unique solution? No, it is not has a unique solution. So which option is not correct one now? Yes, it is unique solution. No, only trivial solution. Trivial means what? Unique solution. That is also known as unique solution. You know the system is clearly homogeneous system. I said to you, it's always consistent means it has a solution. No solution is not at all correct one. Therefore, this is also not correct one. Not only trivial solution is not correct. No solution is also not correct. Det A case of A is equal to 0. What you have? Infinitely many solutions. Infinitely many solutions. We can look at the options 3 and 4. In the option number 3 and 4 also infinitely many solutions is there. So here infinitely many solutions are there, here also infinitely many solutions. Infinitely many solutions also known as non-trivial solutions. Maybe third or fourth option. But we have to recognize which is correct one among the third and fourth options. For that, what is the change here? Here the relation of x and z is given, here the relation of y and z is given. Now we can concentrate on third option. We can collect the x-z relation from the given equations by eliminating the y. If it is not, then we can move for the fourth option. Now verification of, I am eliminating the y from either 1 and 2, 1, 2, maybe 2, 3, etc. I am using the 2 and 3. This is taken as the second equation. This is taken as third equation. Solve 2, 3. For easiness purpose. Here 3x plus 4y plus 2z is there from the equation 2. This is equation 1 you can think. This is multiply with 2 because here 4 is there, here 2 is only. To eliminate the 4, it is also must be 4. That's we can multiply this is by 2. That is 2x minus 4y minus 2, 6, 12z is equals to 0. Now what happened? By addition, these two gets cancelled. 3x plus 2x is 5x. Okay, right. Minus 12z plus 2z is minus 10z. Is equals to 0. This one shall write 5x is equals to 10z. 5 cancel in 10 2 times. For x is equals to z. Yes. x is equal to 2z, we got it. Therefore, which option is 100% correct? It is clearly third option. Clear? So, infinitely many solutions is there in third option as well as fourth option. In the third option, fourth option, there is a relation of xz and yz argument. We got the relation of xz is correctly. So, that's why we can pick up the which option? Third option. Clear? These are the various questions, quick revision I did on the topic matrices, linear equations, part of 3 variables. It's a very important, very easy chapter. There is no difficult at all. We can revise quickly. So, you can do the practice from your side, some more questions. So, already some videos I did on the topic entire matrices, whose links are there in the below description. You can watch it. You can get the complete idea about the matrices. Is it clear? Now, we conclude this video till here. I will come with a new topic with new energy in a new video. Till then, have a great time. Take care. Bye-bye.